Okay, so let's start with our session on mathematical operations using NumPy. So on your screen, I've already started a program and I've defined a very basic NumPy array. Okay, so now quickly, let's start doing a few mathematical operations with it. Now, let's say I want to add 2 to every element. Okay, all I have to do is print a plus 2. Okay, and if I run this, there's a value error. Just a minute, let us see what is the problem. Of course, yeah, I think this should do it. Okay, so if I do print a plus 2, then it's going to print this. Now if I do print a, what do you think is going to get printed? The original one, of course. Now why did this happen is, I have not changed a. Okay, if I want to do change a, what I have to do is a is equal to a plus 2, or what I can do is a plus equals 2. Now when I do print a, right, it's gonna give me the new thing, that is 7, 8, 9, 10. So that is the difference that is there. Now my new a is 7, 8, 9, 10. Now what I want to do is, I want to subtract 2 from every element. Okay, so a minus equal to 2. Okay, now if I print a, I'm going to get back my original a, correct? So that is that 5, 6, 7, 8. Okay, so this is as simple as it gets. So similarly, multiply each element by 10. Okay, a into equal to 10, print a. So this is going to give me 50, 60, 70, 80, right? This is that. Similarly, I can divide each element by 10. So again, a slash equal to 10, right? And now if I print a, it's going to give me back 5, 6, 7, 8. Okay, this slash equal to sign doesn't work. So what I have to do is a is equal to a by 10. So I get 5, 6, 7, 8, and everything is changed to float. Okay, so this is your normal plus minus multiplication division of a NumPy array and all of each of its elements. Okay, now let's say I want to take a square of each element. What I have to do is a is equal to a 2. A raised to 2. For raised to, I have to put asterisk 2 times. Okay. Now if I print a, print the squared values. You can see how simple this Python makes things. Okay. Similarly, you can find a transpose of an array. So for this we are going to require a new array. So b is equal to np dot array. Okay, a list having 2 lists. And what I'm gonna do is, I'm gonna put 1, 2, 3, 4, 5, 6, 7, 8. I'll keep it orderly. Why? Because I want to take a transpose of it. So first I'm just gonna print it as it is, so that it is 1, 2, 3, 4, 5, 6, 7, 8. Now I want to do C is equal to B dot transpose. Okay, so B dot T, if I do, it's transpose, print C. Now this is gonna give me transpose. So there you go, 1 5 2 6 3 7 4 8 transpose. The rows are columns and the columns are rows. So this is how you take a transpose of an array. Now let's say I want to print the max element of the array. Okay, it's as simple as that. Print, I'll go to array B. Okay, B dot max. Okay, so it's gonna give me a built-in object. Okay, so I'll have to assign this, sorry, I have to put parenthesis here, there, and now it's gonna give me a value. B dot max is 8. So 1 2 3 4 5 6 7 8, the max value is 8, of course. Okay, similarly, min element I can find by print b dot min, obviously. B dot min parenthesis. Okay, so I run this, I get 1, of course, which is the minimum one. Now I want to find the maximum element in each dimension. Okay, so max element in each dimension or axis. Okay, for this what I have to do is print b dot max, and now in these parentheses I have to specify which axis maximum I want. So if I want maximum of each row, okay, so it's going to give me 4 and 8 if I do this, right? 4 and 8. Now if I want maximum of each column, okay, so we have got 4 columns, 1 5 2 6 3 7 and 4 8. Now if I want to print max of each column, I have to do b dot max axis is equal to 0. Okay, I have again not put parentheses here. There we go. So 5 6 7 and 8, obviously that is the max of each column. So this was max and min. Now let's find the sum of all elements in an array. See, as you can see, this is very simple, right? So D is equal to B dot sum, right? Now if I do print D, it's going to give me the total of 1 2 3 4 5 6 7 8, which is 36. Okay. Similarly, if I want to find cumulative sum along each rows, okay, now for your sake, I'm going to print B again. Okay, so B is 1 2 3 4 5 6 7 8. Now I want to find cumulative sum along row 1 and cumulative sum along row 2. So what I have to do is I have to do print, okay, B dot CURSUM, okay, axis is equal to 1. As simple as that. So now when I do, okay, sorry about that, I think it's CUMSUM. There you go. So it's 1 3 6 10 5 11 18 26. So this is your cumulative sum along each of these rows. Okay, so these were your basic arithmetic operation things that you can do with a NumPy array. Now let's move on to a few binary operators of NumPy array. Okay, so if we have two NumPy arrays, how can we play with them? That is the question. So let me have a NumPy array. Okay, H is equal to np dot array. Okay, and let me have 3 lists in it. Okay, 1, 2, 3, 4, 5 and 6. Okay, now let me have another array. I is equal to np dot array. Again 3 lists in it. 11, 12, 13, 14 and 15, 16. Okay, so now I want to add 2 arrays. Okay, if I want to do that, okay, all I have to do is print a plus h plus I. So if I just add these two, okay, I am going to get again I've made an error in defining these arrays. I have to make a list of lists. I've just made 2 lists, 2 tuples with lists in it. Yeah, now this is how it's gonna work. So these are my 2 arrays h and I, and here, and this is my h plus I. Okay, add 2 arrays. So it's gonna be 12 plus 12, 14, 16, 18 and 20, 22. So it's gonna add these, and gonna add these. Okay. For better understanding, let me just print h, print I, and then I'm printing the sum. Okay. Now when you see this, okay, wait, let me also add a gap between them. There you go. Yeah. So this is age 1, 2, 3, 4, 5, 6. This is I 11, 12, 13, 14, 15, 16. And this is h plus I, which is the sum of these arrays. Okay. Adding 2 arrays. Similarly, array multiplication can also be done. So multiply 2 arrays. Okay. For this, all I need to do is print h into I. There you go. So this is the multiplication of these 2 arrays. Okay, h and I. Now let me do matrix multiplication. Okay, if I want to do matrix multiplication of 2 arrays, all I need to do is print h dot b. Okay, so if I do this, this is your matrix multiplication of these arrays. So if you remember matrices in school, when you multiply 2 matrices of this orders, you're going to get this value. Okay, so this is your matrix multiplication, right? Now what we are going to do is we are going to do a few trigonometric functions and other mathematical functions. Okay, okay, let me take this right up here. Okay, so this h plus I, okay, we can also use a function called np dot add function. Okay, np dot add. It works in the same way. Here you can use np dot multiply function. Similarly, there's np.subtract, np.divide, np.sum. Okay, so all these things are almost similar as above. So I'm not covering those. Why? Because you can do it in this way, and this is a much cooler way of doing it, isn't it? Now, what I want to do is, I want to run a trigonometric function. So let me make a trigonometric array. So A is equal to, instead of A, let me put T is equal to np.array. Okay, and again I need a list. In that there's going to be 0. Then there will be np.pi, that is pi. np.pi is the code for the pi 3.142 value. Okay, so that's your second, pi by 2. Okay, then there is np.pi divided by 4. That's your third value. And np.pi itself is your fourth value. So this is your np array. Okay, let me just print this array again for the sake of looking at it. There you go. So this is your pi by 2, this is your pi by 4, and this is your pi itself. Okay, so this is your array as it's defined out here. Now, let's say I want to find the sign of sine, cos, tan of this. Okay, so all I have to do is print np.sine a. Okay, let me copy this. Here let me put cos. Let me put tan. There we go. So I get the value of sine of each of these arrays out here, sine, cos and tan, right? Now let's say I want the exponent of A. Print exponent of array T, right? So for that all I have to do is print exp of T. Okay, and here I don't know why I've done A. It should be sine of T. Sorry for that. Cos of T and tan of T. It actually took array A and found out all the values, which wasn't our purpose. So here, this is your actual value, sine, cos and tan of T, right? Now here you have to print np dot exponent of T, right? And that will give us the value of the exponent. So this is your array T. This is your sine of T. This is your cos of T. This is your tan of T. And this is your exponent of T. Okay. Similarly, if I want to find square root, okay. So let's go back to our basic array A. Okay, this one. I'll just redefine it here for the purpose of simplicity. Square root, okay. So A is this, okay. Now I want to print np.sqrt, okay, of T, of A, sorry, A. So this is going to give me the square root of A, which is this. Okay, just for simplicity, let me write square root here so that there's no confusion. So square root is this value right here. So these are a few NumPy mathematical things that you can do with NumPy arrays. Now lastly, I want to show you sorting of NumPy arrays. Okay, if you remember the list.sort method which we had when we were doing lists, okay, NumPy has a similar method, np.sort. Okay, so let me define a nice juicy numpy array. Okay, z is equal to np dot array. Okay, again I'm gonna add 3 list to this. Okay, and I'm going to populate these lists with a few numbers: 2, comma, -7, comma, -1, 3, comma, -8, comma, 2, 4, comma, 9, comma, -2. Okay, so this is my NP array. So I've just added a print value here, and I'm just printing out the array just for the sake of looking. So this is our array that we are looking to sort. Now what I have to do in order to sort this, I have to do print np.sort. Okay, then I have to give the array name z, and then I have to specify which axis. So initially I don't want to sort it on, I don't have any specific axis to sort it. Okay, now when I do this, it's gonna, okay, there is a bracket missing. Yeah, there we go. So now when I do this, it took this array, okay, and sorted it, okay, without any particular order. So this is how it sorted the array. Now what I want to do, I want to sort the array row wise. Okay, sort row wise. Now for this purpose, I have to do print np.array. Okay, again I have to give z axis is equal to 1. Now if I do it this way, okay, look at this. Axis is invalid. Axis is equal to just a moment. Okay, I realize it's np.sort. Instead of that I wrote np.array. Silly mistake. There we go. So now this is sorting it row wise. -7, -1, then 2, -8, 2, 3, -2, 4, 9. So it's obviously going in an ascending order. Similarly, if I want to sort it column wise, so just go sort column wise. Again I have to do print np.sort, the array name and axis equal to 0. So if I do this, it's gonna sort it column wise. So again 2, 3, 4, -8, -7, -9, -2, -1 and 2. Okay, so this is how you do it column wise. And there's something called as a merge sort also. Sort column wise, merge sort. Okay, so in this case you have to do np.sort z axis is equal to 0 and kind is equal to merge sort. There we go. You pretty much get the same answer in this case, but in a case where the array is slightly of a different shape, you will get a different answer when you use merge sort. Okay, so this was sorting example using NumPy. Okay, so finally let's end this session with a sorting example. Okay, this is a pretty cool example, you're going to like it. So I have got an array, okay, with a few students' names, their graduation year and their CGPA marks. Okay, all of them in a tuple. Okay, and all these three are NP I've got in a list. Okay, now as you can see, this is this is a string, this is an integer and this is a float. Okay, Now what I can do is I can put all of these tuples in an array, but I need to define their data type from first. So let me make a string of data types. Okay, I'll call it d types is equal to, I'll again add 3 tuples inside. Now in these 3 tuples, the first thing, why are there 3 tuples? One is for the name, one is for the year, and one is for the CGPA. So the first thing is name, right? And its data type is a string, and its length is maximum 10. I can give a length of the string. Okay, if I don't give a length, it's not going to consider the name. So I'll give a length, a string of length 10. The next thing is the year. Okay, and obviously I can, year is an integer, so that is that. Not very complex. And the last thing is the CGPA. Okay, and this is a float. So again, not very complex. There we go. Right. So this is my data types 1, 2, 3, and there's an extra bracket here for some reason. I'll knock it off and we are good to go. Okay. Now I'm defining a NumPy array. Okay, out here. np dot array, right? Let me call this array as results is equal to np dot array values. Okay, I'm adding this list of tuples values to np dot array, and I need to specify data type here, and for that I'm specifying the tuple d types. Okay, the list of tuples d types. So now when I print results, okay, it's gonna give me this. This is our array now. Okay, Suresh, then 2018, 8.1, Ajay, all that. Okay, now this array, I can sort it by using np.sort value. Okay, so first I want to sort by name. So it's gonna sort by name alphabetically. And later, I want to sort by graduation year and then by CGPA. Okay, so double sort. So first the name one is pretty simple, np.sort. Okay, the array is called as results. Okay, and I want to sort order by name. Okay, I've defined name out here, so it knows that what I have to order it by the string basically. Okay, and I have to print this out, so let me print this entire thing and we are good to go. So there you go, Ajay, Prakash, Ramesh, and then Suresh. Everything is sorted by name. Now what I have to do is I want to sort it by year. Okay, so again I'll do the same thing, sort by sort results. Okay, and order, in order I'm giving it a list. Okay, first I want to sort by year. Okay, and then by CGPA. There we go. So now when I print this, okay, this is what it's gonna do. Ajay 2017, Suresh 2018, Ramesh again 2018, but the CGPA is in ascending order, and Prakash 2020. So this is how it's gonna sort the values like this. So here you can define a varied array with varied data types by mentioning the data types and then keeping them uniform across the tuples, and then you can sort it. So this was a slightly complex example. I suggest that you try it out yourself so that you can wrap your head around it. And with this, we are done with our talk on NumPy. So in these NumPy sessions, apart from installing and importing NumPy, we learned what is a NumPy array, all these ways to create a NumPy array through the zeros, the ones, the random, arrange, reshape, flatten, then the array indexing part of it, and slicing, of course, mathematical operations, binary operations, trigonometric and other mathematical operations, and finally sorting of arrays. So hope you've understood this NumPy, basic stuff on NumPy. Okay, our knowledge of NumPy is now good that we can adapt it to whatever project we require just by a little bit of googling and a little bit of a few more advanced concepts wherever required. Our basics are in place now. So now let's move on to the next module. So see you in the next module. Bye.